Hello. Ray tracing is about tracing rays. A ray flies through the scene and detects materials, and it has the property of creating reflections. It depends on the diffuseness, reflectiveness of a material, and it can penetrate the material like water or glass, and then a certain amount of rays comes back and reaches the camera, the virtual camera in our case, and this produces different kinds of results. I want to show you just basics about Arnold and refractiveness, which has to do with opacity and transmission. Okay, we get started with a polygon plane, which serves as our reflective, actually not reflective surface where we place objects on. Right mouse click, assign new material, and this time we can go for a simple Lambert shader because it should not reflect anything. It should just be sitting there. Let's check this icon here in order to see the textures. We want to map this with a checker, and we want to place the checker more densely, like maybe 20 by 20 here in the placement node, so we can see things a much more detailed way of reflection here. So we need an object now which does the reflection, but before we do that we place 4 or 5 red spheres in the scene, which makes things even more delicate. So let's make it red. Right mouse click, new material. Again, a Lambert is fine, and we just click on the color icon and choose a very reddish cold red. So the sphere is sitting here now, and we move it to the left, and we press Ctrl D in order to duplicate it, and then we press Shift and D in order to repeat the last duplication with transform. So we have a few spheres right here. Okay, in order to render this whole scene we need a light, so we go to Arnold, Lights, and Sky Dome Light. It's a very simple light. It doesn't distract us here in no way whatsoever. So let's move this a little bit to the back and do a quick render of this scene. Arnold render. It looks pretty much the same, but in addition we have the nice warm shadows of this single light scene here. Okay, 6, 8 spheres, that's fine. Now let's create an object which will serve as a lens. A sphere is good, and we can scale a sphere so it gets flatter like this. That's what it looks like now. And now we'll introduce our refractive material. New material and Arnold standard surface shader. It comes in white, and this is the way it renders. So it doesn't let light through, but it reflects slightly the checkerboard, which is on this side, from this side. It's not letting any light penetrate it. We can, of course, change this, and we can change another thing here. We can change the specular weight, for example. If we reduce the specular weight, the reflection will be gone, so it won't reflect the checkerboard in the front of this object. Now it does reflect. We can change the roughness, etc. The crucial value which we'll deal with is the IOR, which is called the index of refraction, and it's currently set to 1.52. I think that's water. That's a refractive IOR value of water. Do we currently see it at work? Well, let's go to a smaller value like 1. And now you see the reflection is still sort of there. slightly, but it doesn't warp the checkerboard anymore. It's a lens effect, basically. And if we change it to 2.2, it sees much more of the reflection here and shows much more of the reflection of the whole plane here. But it shows nothing of the spheres in the back. Okay, let's reduce the index of refraction to about 1.6 or 1.5. And now go to the next section, which is called transmission, and that's our key thing today. So currently the transmission weight is set to 0, which means the object is totally intransparent. So when we shoot the value up to 1, it's totally transparent, and we see a very, very strong refraction here. Lots of things happening in this scene, and Arnold takes a little bit time for rendering. We see that the scaled sphere is working here because we see that double rim here, which is sort of the back and front of this flattened sphere. So it's pretty realistic, and it has a very strong refraction. And the reason is, of course, this value here, although it's not under transmission, it's this is the crucial value here under specularity. Actually, you can reduce the specularity to 0 and still have that refraction during the transmission. Let's reduce the IOR again from 1.5, which is sort of glass and water, to 1. And now you see the lens is totally transparent. It is like a window glass, which doesn't do any big reflection at all. The value is set to 1.007, which is basically 1, but which is not 1 exactly. And especially at the corners of the object, you see very nice effects here for transparency. So what we'll do now is we scale this object up and we move it to the left. And we do another rendering here. So the object is here, and you see nice effects like over here. But all these effects are very, very nice, and we have a really, really small index of refraction. So the next object we're introducing is right mouse click on this icon. Don't click on it, right mouse click on it, and choose the spherical harmonics. The reason for the spherical harmonics is that they are really interesting, complex objects. So this is what jumps into our scene. Where is our lens gone? It's still here. See, here it is. But since it's totally transparent, we don't see it in the viewport, and we barely see it in the rendering. We give this object the same shader, so assign existing material, which is the AI standard surface, so it's transparent now too. Doesn't make a big difference. So we have two lenses now, the left one and the right one, and they both have the same small refractive factor. But we go to the Polysuper Shape 1 here, and probably this is closed. Open this section, please. We have spherical harmonics, okay? And we have a section about spherical harmonics where we can tune the fine parameters. So open this section, please, and just play with the parameters. Like this, like this, like this, like this, and maybe this, and this. Okay, so we have an interesting object here. And of course it looks transparent because it has the transparent shader. Now let's go a little bit away from the scene and scale this massively up. So it covers most parts of the red spheres in the background. And also let's hide the small lens we had before. Control H, hide. So let's render the scene now. So this is a very impressive view, really. We have a complex object and Maya sends lights through the scene. Actually, Arnold renders the whole scene, and it's very, very complex. Let's get a little bit closer to it, like this. Render it again. There are details which you can read in the documentation, which is here. Here you have lots of little things, like even with animations here, how the transmission depth works with certain geometries. Probably our geometry currently is too simple for this. So this is the page where Solid Angle offers help for, or actually it's a manual about transmission, and you can search the page. I search for depth, for example, and you find 15 entries about depth in this single page here. Well, that's it about refractions. Have a nice day.